different people have made different trade-offs. And that's really what we're going to be talking about today is here are the trade-offs that we made, here are the choices that we made, here's why we did them, and here's the benefits that we get for our customers and use cases. So first, the disclaimer. So this is based on public sources for each company. I only work for one of these companies, so I have to go off of what they publicly say about their architecture. So if it's wrong, I either read the source wrong or they didn't actually disclose it accurately. We won't be covering every all-flash array architecture because, quite frankly, some of the ones that are out there are not all that different from traditional arrays. Other ones don't have a rich set of features, and so, frankly, their architecture just doesn't have that much to talk about. And some just aren't that well documented, right? There's just some out there that they haven't really disclosed anything about the architecture, so I can't really talk about it. So system scale. So how are capacity and performance scaled in the architecture? Of these three architectures, one is a fairly traditional scale-up architecture. This is the traditional model for block-based storage, is the scale-up model, and that's not necessarily a bad thing, right? There's a familiarity with the scale-up model that a lot of administrators have, and moving to flash, a lot of times they want to carry over with a similar model. You get more performance out of a scale-up model by moving to more powerful controllers. That's why it's called a scale-up model. Typically, these companies have a line of controllers with more CPU and memory in them that gets better performance as you move up the line, and also by adding more spindles. Now, in the flash-based world, that doesn't always necessarily get you more performance. More capacity comes from adding more disk shelves to the system. And once you really reach the limitation of your controller, once you've got your fastest controller and you've kind of maxed that out, you've got to get more capacity or performance by adding additional storage systems. So you could start with a theoretical system that has 20 terabytes and 200,000 IOPS. So this isn't theoretical. I think this is their spec sheet. And then you can add more disk shelves and get more capacity, but you're really not getting any more performance because the controller is actually the limiting factor on performance. And in the scale-out architecture, you generally scale performance and capacity together in some case. So you actually add more controllers over time to get more capacity. We call those nodes. They call those bricks. Typically, those controllers are attached to some amount of capacity. In our case, they're internal. In XtremIO's case, they use a disk shelf. But in either case, you're getting more capacity with more performance. One of the nice things is if you have a mix of capacity and performance you like, it's not going to get out of whack over time as the system scales. And that's been one of the traditional problems with scale-up is I can add more capacity to it, but now my ratio of capacity and performance is different. And that means I either had to buy a bunch of performance up front that I didn't need, or I didn't buy the performance and now I'm out of performance and I've got to upgrade my controllers. Now, one of the unique things about SolidFire that XtremIO certainly doesn't offer today is the ability to get to an overall balance of capacity and performance with different node types. So you can build a cluster with a lot of performance and a little bit of capacity, as we saw on that graph, or a lot of capacity and a little bit of performance, or mixed nodes to get whatever balance you want. So you don't really have to feel like you're stranding either one of those as the system expands. And of course, with SolidFire today, you can scale out the system and get balanced load as the system scales automatically. You don't have islands of storage. Not that you can't have multiple SolidFire systems, but those islands, if you will, are going to be much larger management domains and entities. You have to play less kind of manual management games to keep everything balanced. So comparing and contrasting these, we've talked about a lot of these points. You know, one advantage of scale-up is it's frankly easier to engineer. There is a lot of complexity when you get to scale out systems. Distributed systems are very difficult. A huge percentage of the code in our system deals with the scale out distributed systems nature of the system. They are a lot harder things to engineer. That's why almost nobody in the industry has ever added scale out to an existing scale up system. Nobody's really ever done it because it is something that really needs to be engineered from the beginning. Scale out obviously gives you the ability to scale to higher more significant capacity and performance levels, a simpler upgrade path, and the possibility to actually remove nodes and downgrade. If I had to sum up, I would say that scale up is really better for small, fixed, predictable workloads. If I know what my workload is and I can size a system, capacity and performance to fit that, very easy, put it in, live with it. If you have larger scale, if you have unpredictable growth, the flexibility of a scale-out model is, I think, the better path. And I think that's why the majority of the interesting development in the storage world right now is in scale-out models.